Hello and welcome to my intermediate fluids project. My name is Rizwan Shukoor and I am the only one in my group. I've decided to build a converging diverging nozzle for my project based on compressible flow. The question number is 64 in chapter 12. And in this project that I'm going to use ANSYS, which is a CFD tool, in order to simulate it and get proper results. The first step obviously was to build a geometry for the converging diverging nozzle, and in the next view I'll show you how it was built. I'd used various line tools and constraints such as symmetry in order to build it properly. After this I had to also use the mesh tools in order to create a proper mesh. The various steps that I'd used is automatic method, edge sizing, face meshing, etc., and I'd used square faces for my mesh. Moving on to the next step, which is the solutions. I'd started with building this system. The first thing that I had to do is go on to general, and I'd clicked on pressure-based systems, which is what was suggested for compressible flow, and everything else was pretty much kept the same. I turned on the energy equation and set the fluid as inviscid. The next step was to go to materials, and I had to change my air to an ideal gas. Moving on to the next part would be the boundary conditions. I had not mentioned it before, but I'd also defined the various boundaries earlier when I was making the geometry, and I'd gotten the inlet and outlet conditions, which is what was changed. I changed the inlet conditions and pretty much built my system off of that. The next big step was to go into solution methods, and I changed it from simple to coupled, which was what was suggested for a compressible flow inside a converging diverging nozzle for Mach numbers under 3. The next step was to turn on the residual monitors, and also I had created a report plot as well. The next part of this project involves initializing my simulation, and I changed it from hybrid to standard simulation. I'd put in all my input values, and I'd initialized its calculations. After the fact, we run check case, and and I kept the number of iterations to about 1,000, and then I'd run the calculations. I would run one round of calculations in this video in order to see how it varies with time. As you can see that this is starting from 1,000th iteration. This is because this is the second time I'm running the calculation in the same for the same mesh. I've also done these calculations for 4 other meshes for the mesh independence part of my project. As you can see, the calculations seem rather steady, and it means that what we are getting is our results aren't varying much, and there's not much fluctuation in what we're getting. Moving on, we also have to make contour plots for our design and for our simulation, and then these contour plots are then later viewed on the results window, where I copy paste it, and I compared the results from that with the results that I'd gotten from hand calculations. And in this window I move on to the results. These are the various results that I'd gotten for my simulation, and this is the first one that I'm looking at is pressure. The next is the temperature variation, and you can clearly see that there is also a very well defined normal shock wave that exists in the system, which is as expected. I'd also check the Mach number of this of the flow right before the shock wave, and it was around 2.49, which is very close to what is expected from our system. So that's about it for my project, and